Alright guys, here's your lesson for section 13.1, the first day of right triangle trigonometry. So what we're dealing with today is we are going to be looking at ratios for right triangles and solving right triangles. So this is your indicator that you have a right triangle. We have our angle over here, theta. We have three trig functions, sine, cosine, and tangent, that relates the sides of your triangle to the angle. Okay, so when you're setting up these ratios, I highly recommend that you label the sides of your triangle. So you're focusing on your angle. If you go directly across to your other side, that's going to be your opposite. So your opposite side is directly across from your angle. Across from the right angle is always your hypotenuse, and then the side that's right next to your angle is your adjacent. So sine of theta relates your opposite side with the hypotenuse. So sine of theta is opposite over the hypotenuse. Cosine of theta is your adjacent over the hypotenuse. And tangent of theta is the opposite over the adjacent. One way to remember these ratios is to remember SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So there you go. There are three other trig ratios, which are reciprocal functions of sine, cosine, and tangent. So the reciprocal function of sine is cosecant. The reciprocal function of cosine is secant. And then the reciprocal function of tangent is cotangent. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. If cosine is adjacent over hypotenuse, secant is a reciprocal of that, so hypotenuse over the adjacent. And then finally, tangent is opposite over adjacent, so cotangent is adjacent over opposite. So let's actually set up all 6 of these ratios using this triangle. So I'm going to go ahead and label the sides that I know based off of my angle theta. So if I go directly across the triangle, that is the opposite side. Across from the right angle is the hypotenuse. So what I'm missing is the adjacent side. And we can solve for the adjacent side using the Pythagorean theorem. And we want to solve for the adjacent side because we need to know all 3 sides to be able to set up these 6 ratios. So I'm going to go ahead and label this side b. So I have a squared, so 5 squared plus b squared equals 13 squared. So that gives me 25 plus b squared equals 169. So b squared equals 144. So that side is 12. Alright, so I have all 3 sides. I'm going to go ahead and set up the ratios. Sine of theta is my opposite over the hypotenuse, so it's going to be 5/13. Cosine of theta is the adjacent over the hypotenuse, which was 13 as well. And then tangent of theta is the opposite over the adjacent, so that's 5/12. From there, I'm going to go ahead and do the reciprocal functions. So cosecant of theta is going to be the reciprocal of sine. Secant of theta is a reciprocal of cosine. And then cotangent of theta is a reciprocal of tangent. And these are the 6 trig values that I wanted you to find. Now what we can do is we can take our trig ratios, sine, cosine, and tangent, and actually use them to solve some problems. So you always want to start by labeling the 2 sides that you know in reference to this angle. So here's the angle that I'm focusing on. The side x is across the triangle, so there's your opposite. The side label with a 10 is next to your angle, so there's your adjacent. And you want to use SOHCAHTOA to figure out which trig function you're going to use. So this says that we have our opposite with the adjacent. So the one that has the opposite with the adjacent is tangent. So I'm going to use my tangent function. So it's tangent of my angle equals my opposite side over the adjacent. When we're trying to get x by itself, it's being divided by 10. So I'm going to go ahead and multiply both sides by 10. So I get x equals 10 times tangent of 22 degrees. I'm going to go ahead and plug that into my calculator. And I'm going to round to the nearest tenth, so that's going to be 4.0. For this triangle, again, focusing on that angle and how those two sides relate to the angle. So this side is right next to the angle, so there's my adjacent. This side is across from the right angle, so there's your hypotenuse. So you're looking for a trig function that uses the adjacent with the hypotenuse, and that's going to be cosine. Wrong color. There we go. So I have cosine of angle x equals my adjacent over the hypotenuse. Now right now your x is stuck inside the trig function, so to be able to extract it out and solve for it, we want to use the inverse. So whenever you're solving for an angle measurement, you always want to use the inverse. So it's going to be the inverse cosine of 5/8. I'm going to take that and plug it into my calculator. Inverse cosine of 5/8. I'm going to round to the nearest degree, so it's 51 degrees. So trigonometry is very applicable. You use it a lot in surveying, constructing, trying to find distances and stuff like that. So it's only natural that we have application problems. The key with these is drawing a picture, setting up your triangle, and then using sine, cosine, or tangent to solve for whatever it is the question is asking for. So the aerial run in Snowbird, Utah has an angle of elevation of 20.2 degrees. Its vertical drop is 2,900 feet. Estimate the length of this run. So we have people skiing. Angle of elevation starts at the horizontal and goes up. So this right here is your angle of elevation, and we know that that is 20.2 degrees. The vertical drop is 2,900 feet. So this side is 2,900 feet. The length of the run is the portion that people would actually ski off of, so this is what we are trying to find. Okay, so I can go ahead and label my sides. Here's my angle, this is my opposite side, and this is my hypotenuse. So I'm trying to find a trig function that uses opposite with hypotenuse, and that's going to be sine. So I have sine of my angle equals my opposite side over my hypotenuse. Trying to get my x by itself, it's stuck in the denominator, so I'm going to go ahead and multiply both sides by x. And that gives me x sine of 20.2 equals 2,900. I need to get my x by itself, so I'm going to divide both sides by sine of 20.2. So I'm going to take this and plug it into my calculator. So I have 2,900 divided by sine of 20.2, and I'm going to round to the nearest foot. So it's 8,399 feet. So the length of the run is 8,399 feet. Bridge construction. In order to construct a bridge across a river, the width of the river at that location must be determined. A stake is planted on one side of the river, directly across from a second stake on the opposite side. At a distance of 50 meters to the left of one of the stakes, an angle of 82 degrees is measured to the other stake. Find the width of the river. So I'm going to go ahead and draw a picture. I'm going to draw my river. And we're trying to figure out how wide this river is. So this is what we are trying to find, so I'm going to go ahead and label that with x. Now we have a stake planted on one side of the river directly across from a second stake. So we'll say this is your first stake, and this over here is your second stake. At a distance of 50 meters to the left of one of the stakes, an angle of 82 degrees is measured to the other stake. Now, the question doesn't specify which stake you're moving 50 meters to the left of, so I'm going to go ahead and move 50 meters to the left of my first stake. So we know that is 50 meters. And an angle of 82 degrees is measured to the second stake. So you're standing over here, and you measure an angle of 82 degrees to your second stake. So this is your right triangle. And now you can use that to solve for the width of the river. So I'm going to go ahead and label my sides. This is my opposite side. This is my adjacent. So the trig function that uses opposite and adjacent is tangent. So I have tangent of 82 equals my opposite over the adjacent. I'm going to go ahead and multiply both sides by 50 to get x by itself. So I have x equals 50 tangent of 82. And the width of the river to the nearest meter is 356 meters. All right, next one. Surveying. A surveyor stands 100 feet from a building and sights the top of the building at a 55-degree angle of elevation. Find the height of the building. So I'm going to go ahead and sketch my building. There's my building. It's always fun to draw a picture. Here's my surveyor hanging out over here. He is 100 feet away. Angle of elevation, so he's looking towards the top of the, that's a terrible line, whatever, but he's looking towards the top of the building, and we know that this angle is 55 degrees. And we're trying to find the height of the building, so I'm going to go ahead and label that as x. So again, we have our opposite side of our angle, and we have our adjacent side. So I can go ahead and use tangent, because tangent's opposite over adjacent, to solve for the height of the building. So I have tangent of 55 equals opposite over adjacent. I'm going to go ahead and multiply both sides by 100 to get x by itself. So x equals 100 times tangent of 55. And that gives me about 143 feet. So the building is 143 feet tall. The Americans with Disabilities Act, ADA, provides regulations designed to make public buildings accessible to all. Under this act, the slope of an entrance ramp designed for those with mobility disabilities must not exceed a ratio of 1 to 12. What is the maximum angle the ramp can have? All right, so I'm going to go ahead and draw a ramp, which just so happens to be a right triangle. So the slope of the ramp, if you recall, slope is rise over run. So the ratio of this side over this side cannot exceed 1 to 12. So I'm going to go ahead and label my vertical side as 1 and my horizontal side as 12. Okay, so it can't be higher than, the ratio can't be bigger than 1 to 12. So what is the maximum angle the ramp can have? So what we're solving for is this angle over here. So I'm going to go ahead and label my sides. Here's my opposite, because it's opposite my angle. This is my adjacent. And again, we're using tangent, because we have opposite and adjacent. So I have tangent of theta equals opposite over the adjacent. Now I'm solving for an angle. I'm not solving for a side, so that means I want to use the inverse trig function. So I'm going to take the inverse tangent of 1/12. I'm going to go ahead and round to the nearest tenth, so that's 4.8 degrees. So that means the angle cannot be bigger than 4.8 degrees. Ladders. A 20-foot ladder is leaning against a wall. I'm going to put my building there again. I'm going to draw my ladder leaning against the wall. Not the best ladder, but that's okay. It is leaning 3.2 feet away from the wall, so this distance is 3.2 feet. We know the ladder is 20 feet. We want to find what angle does the ladder make with the ground, so we are trying to find this angle over here. I'm going to label my sides. The 3.2 is the adjacent side. 20 feet is a hypotenuse. So adjacent and hypotenuse is going to be cosine. So I have cosine of theta equals my adjacent over my hypotenuse. Again, I am solving for an angle, so I'm going to do the inverse cosine. So I'm going to take the inverse cosine of 3.2 divided by 20, and that gives me 80.8 degrees. Alright, so that'll do it for 13.1 day 1.